So that's my primer on Juno.
Will there be any investigation of the lightning?
Oh yes, I believe so. The lightning seems to be, that was one of the Galileo results, right? That that there was a very different kind of lightning there, and I think there may be some of these high energy particle detections, but I'll have to look that up. I'm not sure exactly what we're doing with the lightning.
Because that's kind of crazy to think of big lightning storms in the cloud tops of Jupiter.
I would love to see that. On the night side, you just would continuously see these big, huge lightning flashes. That would just be wonderful.
And then I also have to ask, you said a partnership with Lego. What's the partnership? I see where you're taking 3 Lego people, but I mean, that was a,
Well, actually, so what Lego's doing for us is that they're starting a number of sort of summer science build-it-your-own projects that are on the Lego website, and one of them is going to be featuring Juno and some other NASA missions. So they're doing some great science outreach for us. By the way, I would love to see what happens to those minifigures, because in February 2018, we're going to deliberately dive Juno into Jupiter. We're going to destroy it. And being spacecraft-grade aluminum, these little things should survive quite long. So, I mean, you're going to dive through the clouds, and then you get to the sea of liquid hydrogen. And I'd love somebody to calculate how deep they're going to last, as they get down into that sea. I don't suppose there's a
camera on them,
no,
is there?
Well, I mean, like, it's going to burn up.
Raiders of the Lost Ark, and they melt away in there.
It'd be exactly like that. No, I mean, absolutely. So, I mean, I think Junocam will melt before these little figures will, so that we won't get any images of that. We call it the Viking funeral. And, Galileo did it. It burned up in the atmosphere of Jupiter. Cassini will do it for Saturn later on. So that's going to be really sad. I'm going to miss the hell out of Cassini. I love Cassini. Yeah.
So questions? Yes.
So I might be interpreting the thing wrong, but the camera didn't look like it was inside the radiation housing.
Yeah, I think that's right. It's not in the same vault as everything.
So what are the odds that it gets kind of fried,
Yeah.
Right, slapped on the last minute and gone on the first plunge.
I'm not actually an expert on exactly where they place the camera. There's probably some sort of shielding a little bit, but I do know that it's almost an exact replica of the Martian, the Mars Curiosity MARDI camera. And the Mars cameras have to work in pretty high radiation environments too. So I think that, this was a lower cost, slightly last minute addition to the mission. So, I mean, it's going to be a wonderful thing. I'm really looking forward to it. But it's going to last. It's totally going to last the whole time.
Yes. Okay.
You said we're going to be able to sense the atmosphere down to 1,000 bars. That's what, 500 miles?
Something like that.
How deep is the atmosphere? How far further down does it go?
Well, I mean, that's one of the things that's model dependent, I think, is what you have to say. That we have models of what we think the interior of Jupiter is like. At some point, you get to liquid hydrogen. You go from the gas to liquid hydrogen, and then you get to the liquid metallic hydrogen after that. I don't have a number exactly. I've heard about a quarter of the way in to a third of the way in is where you start getting the liquid metallic hydrogen. But one of the really, it doesn't sound as exciting as it is for scientists. The thing about this mission is it's going to constrain models like crazy. I mean, once we have the pressure observations, the temperature, the composition, the whole idea of the presence of water and how much water there is, it's a really good excuse for us to decide which of our models of Jupiter's formation are more correct than others. Because depending on how fast Jupiter formed, did a rocky thing form and then an atmosphere formed around it, or did the whole thing collapse in one big mess? There are actually different predictions for the abundance of water. So,
Thank you. Amplified. That's
so the exact interior and how deep the clouds are is dependent on our models of the planet. I think it'll be better after this mission.
Yes, there.
The short film from NASA talked about all the material shooting off of Jupiter and everything, almost like projectiles. How do you protect Juno against being struck? It's going 160,000 miles an hour. Now there's a meteor out in the lobby that's made of iron. What do you do to, how does it not get hit?
Nothing. We got nothing. There's no way to avoid it, right? I mean, there's no sort of fine guidance where we're going to see something coming and then get out of its way or anything like that. So that particular part of the video, I do kind of have my slight doubts about. I mean, it's all true but I think it's very unlikely that we'll encounter something I mean, so the idea is that if there really is a rock or even high velocity dust, there is a chance tomorrow that we get blown to smithereens, but it's a very, very small one. And, you know, I mean, it seems to me that, you know, most of the stuff around Jupiter falls in pretty fast. So, you know, I mean, yes, there's lots of debris around Jupiter. It certainly attracts lots of things. But when you saw the animation of it flinging off comets and everything like that.
Yes,
oh.
it looked like a battlefield.
Yeah, yeah. We're going to cross our fingers. I think it would take some very bad luck. It's possible. But I mean, we're with any degree of reasonable luck, and let me find some wood to knock on. So touch wood. You know, we're going to be okay. Yeah.
Right.
Yeah, we've had spacecraft orbiting there before. Galileo was there, and it lasted many, many years, and was fine.
In the very back there.
Yeah, what is the actual distance of Jupiter to the Earth, and how long does it take for a command to get to the spaceship and then for it to give it back to us?
So as of Monday, it's going to be 540 million miles away, and that's always changing, right? Because of course, you know, the Earth and Jupiter are planets that both go around the sun. And so sometimes we're fairly close to Jupiter and sometimes we're on the other side. So 500 million miles away is certainly not opposition. It's not closest approach. I believe the time for the signal is approximately 48 minutes. Yeah, anybody, right?
Sounds right.
Yep. So about 48 minutes to get the signal back. Yeah.
But that's, you double that to send a command out,
Yep.
and then get verification that it was received.
Yeah, I mean, we're mainly going to be in passive mode tomorrow. I mean, we're going to be looking for what are called tones.
Are you referring to Monday?
Oh, sorry, Monday.
Okay. Because
Yeah.
you said tomorrow several times. I just want to be sure.
Okay.
That all of those
I
refer
mean
to
Monday. So I mean, I'm what they're doing to me today is panicking me because they I got to JPL just today and they were like, you know, you're going to start at 3 a.m. on Monday doing news stuff for the morning news shows on the East Coast, and then the event doesn't happen until 8 o'clock at night. So I'm a little worried about how I'm going to survive that day actually.
Lots and lots of coffee.
So
Yeah.
Monday, yeah, I mean Monday. I did that to my friend. Poor Brandon's going to come, right? And I was like, it's tomorrow, and I'm like, no, it's not. It's Monday. So you know, I mean, it's all Monday, and it's going to be a hell of a day. So I'm actually really looking forward to it.
What programs are you going to be on?
Well, what program? So I do a lot of what they call live shots. So when you turn on the news and there's a NASA scientist telling us about the latest thing that's going on, and they do these like 1 minute or 2 minute interviews. At the moment, I'm lined up for 30. And
Are you going to have to go back on Fox News and have them accuse you of being a hoax?
oh, I hope so. Yeah, that was a lot of fun.
Jupiter,
Yeah,
not
that's right.
really there, made in Hollywood.
Might as well be, absolutely.
Okay,
Yeah.
there was a question up there.
Could you explain more about the radiation around Jupiter?
Yeah, the radiation is really fascinating. I mean, it's something that we need to understand a lot better. So as I mentioned, Jupiter has this huge component of metallic hydrogen. And that metallic hydrogen is rotating and convecting, and all of that moving metal generates a huge charge. And in fact, the magnetic field of Jupiter, I mean, there's some argument exactly what you want to count, but it is certainly one of the largest structures in the solar system. You know, it's something on the order of like 15 times the size of the planet. It's a huge, huge thing. It extends very far out. And, you know, it's one of these things where it really is almost kind of like a little star with its own solar system. And there's this giant magnetic field. There was a real active argument at NASA about which of the icy moons we want to send a mission to. Because you may have noticed that Cassini has been happily floating around Saturn for more than 10 years. And that's because Saturn does not have the intense radiation environment that Jupiter has. So if we were to go to Europa, I mean, Europa is at least a lot farther away from Jupiter than the Juno spacecraft is going to be. But the radiation at Europa is still very intense. And it's hard to make a spacecraft that can stay and study Europa for a long time. Whereas if you went to, say, Enceladus, which is a moon of Saturn that also has an ocean, you could hang out there quite happily for a long time. Jupiter's a dangerous thing. It's a wonderful, dramatic, you know, almost like a star. We're using it as a laboratory for basic physics. Jupiter's magnetic field is so strong. There's so many things like magnetars, right? I mean, we mentioned these neutron stars that have intense magnetic fields. There are places in the universe where magnetic fields are the strongest forces by far. And we're not really used to magnetism being much part of our lives. And Jupiter is this realm that's kind of a midway. We can go out there and study what a super intense magnetic field is like. So we're looking forward to learning more about basic magnetic physics by studying the magnetic field of Jupiter.
There was a question of this young person right there. That would be you.
That would the solar panels get anyhow affected by whatever the radiation is from Jupiter? So yeah.
Oh yeah. I mean,
How would it be affected?
I mean, the thing, the somewhat comforting thing is that all this stuff was already tested at very high radiation levels. I mean, everything should be working, fairly well. I mean, hopefully, but I mean, everything's got to turn on. Everything's got to work right tomorrow. I mean, the whole thing has to be flawless.
On Monday.
Sorry. On Monday, everything's got to work on Monday. I'm so looking forward to this. I just,
you want tomorrow. It's like Christmas. You just can't wait for it to come.
Oh my God. So everything on Monday has to work perfectly. Over time, everything's going to get fried, right? I mean, and it's possible that the mission won't last as long as we hope it will. We think it will, but the radiation will eventually degrade the electronics, and and degrade the performance of the solar panels too. So, but we hope we've got a good 2 years to actually to work. But yeah, they will. They will degrade.
We have a time for just a few more questions,
Yeah.
and it's kind of hard to see in the dark here. So I just want to see how many people have questions. I saw 1, 2, 3, 4, 5, 6,
Dark
7.
Yeah.
Oh my
That's
goodness,
right.
we've got so many.
'Cause they're not in the
so
lights,
I'm
they're
going to
hard to
start
see.
at this
That's
end.
right.
You'll be you, then did I see a hand there? Then you, then in the back. That's 4. And who's in this side?
I'm saying Monday.
And
it's not
then
tomorrow.
5,
Monday.
and then 6, and then that's it. All right. So let's start with you, young man.
So how much information are you guys trying to get when you, dive bomb into Jupiter? Like, how far are you guys going to try to get information?
Well, that's when all the magic happens, is when we do the dive bombing. So the orbit takes us about 2,600 miles above the clouds of Jupiter. That's closest. And then we go out a little more than 5,000 miles. And so we're in sort of this elliptical orbit that takes us in and out. And of course, we'll be doing science all the time. But that's, we really want to get into that interior area, inside the intense radiation, right up against the clouds, flying so close that we can tell how big the core of Jupiter is, because we can look for tiny little differences in the acceleration. So all the magic happens on those dive bombing. And yes, I mean, on the way out, we'll be taking imagery, we'll still be studying. We're going to be sampling a really large region of Jupiter's magnetic field, going into the interior and then out again. So, I mean, while we're doing science through the whole thing, it's all about those dive bombs.
Yes.
So when you talk about radiation, are we talking only about electromagnetic radiation, or are we getting some sort of nuclear radiation as well? Could we use the electromagnetic radiation to fuel the fuel cells?
Oh, that sounds cool. The problem is capturing. So I mean, we are talking about electromagnetic radiation. There really isn't much in terms of nuclear processes going on around Jupiter. But the problem is the capture, right? I mean, yeah, there's a huge amount of radiation, but we're really just thinking of it as a problem more than a way to fuel something up. It almost kind of reminds me, when I was a kid, I was really disappointed to learn that a nuclear reactor, all it does is actually it's a steam turbine. I mean, there's this incredible process of splitting atoms apart, and you use it to heat water and make steam. Capturing the energy from high energy radiation is really, really hard. And so we don't have a mechanism. We don't need a lot of power to fuel Juno. The whole thing runs on about the same amount of power as a blender.
Really?
Yeah.
And makes great.
Makes really
Mai
great.
Tais as
Yeah, that's
well,
right.
right?
Makes great, yeah, that's right. Yeah. So
When
come
it's
on,
not
Drops
observing.
of Jupiter, right? Okay, yeah, that's right. That was my song, Drops of Jupiter. It doesn't take much energy. It doesn't take much power, but we have no way to efficiently capture that radiation.
All right, number 3.
This is on the topic of engaging the public in voting and everything. Has anyone thought of, I don't know, creating like a Twitter account and engaging in social media to release pictures and other data, as well as making voting easier for the public?
We have a whole team. I mean, not only are we on Twitter, the 1 week surrounding the New Horizons flyby, our Twitter footprint was 12 billion. And what I've been doing recently is Snapchat. And of course, that's all fun because it's all gone in 24 hours. So thank you very much. You do something, you got to do it all over again. But NASA has an entire social media team, and this is something that we specifically hire for. So, I mean, we have probably, I mean, at NASA alone, we have several dozen people who are specialists in social media, and they do incredible work for us. I mean, I think that the outreach we get through the social media has blown away everything else we've so far done. And so absolutely. And I would encourage you to look for Juno on Twitter and Snapchat and Instagram and Facebook and Tumblr and Tinder.
Right. And I'm going to be shameless and also say you can look at our Twitter feed for All Space Considered. There is a Twitter feed for that as well. In the back, I think, number 4.
All right, so I think I understood now for the first time that when you're talking about radiation, you're not talking about Hiroshima, Nagasaki type radiation, correct?
Well, basically, yes. It's. I mean, it's not. Yeah, I mean, I think what you're thinking about with Hiroshima and Nagasaki is radioactivity, and those are two different things, two different terms. Yeah.
Oh, okay, sorry.
No.
And when you talked about magnetic radiation?
Well, the magnetic field, yeah, is a source of energy, and that magnetic field accelerates particles in it, and then those become very, very energetic, and they give off a lot of radiation.
And the magnetic field, it's the same sort of thing we're talking about. You take a magnet, you pick up a nail,
Absolutely.
right?
Yeah. Yeah, so when you have a spinning magnetic field, I mean, this is the way that dynamos, engines work. You know, when you spin a magnetic field, in the case of an engine, you can move electrons back and forth through a wire. And in some respects, it's the same thing with Jupiter, that Jupiter has this really intense magnetic field. It's spinning around with the planet very fast, and it is generating huge amounts of electrical current, and that actually excites particles. There's something called synchrotron radiation, where particles get spiraled around a magnetic field, and they give off radiation that way too. So yeah, in many ways, it's the same thing as a dynamo that you'd run an engine off of.
And if you threw your refrigerator into it, it would accelerate around with all the magnets.
It's like, despite all this, it's about 300 degrees below zero, right? The temperature out there.
Well, well, actually, the cloud tops of Jupiter are about 250 degrees below zero. And then it gets very hot very fast as you plunge in. And although this is, again, model dependent, we've never seen this, we believe the core of Jupiter is something like 40,000 degrees, so hotter than the surface of the sun. And so there's some sort of a huge temperature gradient in there. And that's actually one of the things we're hoping to see with this microwave radiometer, is how well that works.
I'm sorry, we have to move on.
Yeah, sorry.
Number 5.
Yes. So I was just curious, how long are you expecting to be able to collect data? Like in your perfect world, everything?
It's a little more than 2 years. Yeah, that's what the mission will last. And specifically, it'll be 36 orbits. And I mean I don't know. A lot of times there are extensions to missions at NASA, and I don't know whether Juno would be available for that or whether that's precluded. Yeah, because at the moment the date of February 2018 is something that they're saying is when they're going to dive it in, and I know that's partially based on how they think that it'll degrade due to radiation, and they want to make sure they have control to do the controlled burn. There's actually requirements now that when you put a spacecraft up in orbit, you have to deorbit it. You can't just leave things as space junk floating around. And the Jovian system is even more special that way because Europa could be an environment for life. Europa, maybe Ganymede, some of the other moons could actually have existing life under the ice. And so we need to be very, very sure we don't contaminate that with stuff from Earth.
And last and not least, number 6.
Once this mission is over, what's on deck for the next generation stuff, specifically for Jupiter and other parts of the solar system?
There's a lot of cool stuff going on. So, I mean, right now we're starting to build Mars 2020, which is the next big Mars rover. It's going to be very similar to Curiosity, but have different science instruments on it. We also have gotten the go-ahead to develop at least one Europa mission, maybe 2. So there's a mission to go and orbit around Europa. We'd like to actually get down on the ice. And JPL is right now designing a series of rovers that are under ice rovers. They kind of actually hug the surface of the ice and go under the water. And yeah, they're not quite submarines. They almost really are rovers. They're wheels that actually kind of
Upside-down
rover. Yeah,
rovers.
upside down rovers. And so Europa is a big target for us right now. But another one is Venus. We have not really explored the planet Venus very well at all. And we really need to understand how Venus works, because Venus is so like the Earth in terms of mass, and it's about the same orbit away from the sun, but it's entirely different. And one of the weird things is that Venus hardly rotates at all on its axis. And it has no global magnetic field the way the Earth does. So a big key for how planets work, if it weren't for our magnetic field to protect us from the high energy particles from the sun, we would have all just died long ago. I mean, we need that magnetic field. And both Venus and Mars don't have global magnetic fields. So there's a real big component to figuring out whether a planet is habitable or not. And we don't have all the pieces of the puzzle.
Are these like wish list projects or funded, or are they funded already?
These are all things that are funded or in the process of being funded. The Venus proposals, I believe, are not funded yet, but we've had a lot of interest in having a Venus mission from the planetary science community. So Mars 2020 is funded. The first Europa mission, probably to map it, the funding's available. Now the question is there more for a lander? That's just the planetary science stuff. Then there's the whole amount of astrophysics stuff that's coming up too. There's a huge amount in astrophysics and earth science.
And you can hear a lot about that on our
James
YouTube
Webb.
channel. We had a guest about 4 months ago, Ken Carpenter, who gave a marvelous
Yeah, I know Ken very
overview
well.
of all the future astronomy missions. I would like to thank Dr. Thaller one more time.
Thank you.